Well, welcome to this discussion about the graphs and applications of quadratic functions. And in this video, we are going to focus our attention on how do you graph parabolas that are in the form of f of x is equal to ax squared plus bx plus c. So as we ease our way into this whole graphing process, we probably want to talk a little bit about, well, what is a parabola and how does that relate to this equation? Okay, so you may or may not remember that a parabola is a U-shaped graph and it is the graph of a quadratic equation. So when you're asked to graph a parabola, it's the same as graphing a quadratic function. Okay, it's just a special name for a quadratic function. So when we graph a parabola, the very first thing we want to focus on is finding the vertex and plotting that, because that is the key point of a parabola. It is the point where the graph changes from increasing to decreasing or vice versa. So the first thing we're going to, if an equation is in standard form, it looks like this. F of x is equal to ax squared plus bx plus c, or y equals ax squared plus bx plus c. Now, if it's in this form, the way we find our vertex is to find the x of the vertex by finding the value of the expression negative b divided by 2a. Now, once I have an x value and I have a function value, it's very easy to find the y value by just subbing it in. I take that x value that I found here, the negative b over 2a, and sub it back in everywhere I have an x. Okay, so finding the key point of the vertex is the very first thing you want to do. Then you're going to find the x-intercepts of the parabola by substituting 0 in for the f of x, or subbing in a 0 for y and solving for x, right? And then find the y-intercept by subbing a 0 in for x and solving for y. So you've got some intercepts, you've got a vertex. You're going to finish this out by substituting a couple of additional values in for x that are close to the vertex. They'll just fill out your curve just a little bit further and make it easy for you to sketch. Okay, so let's give this a shot. Let's try to graph the equation f of x is equal to x squared minus 6x plus 7. Okay, so if I'm looking at that equation, I see it's in standard form, that ax squared plus bx plus c form, and I can start by finding the vertex. And I'm going to find the vertex by finding the x value first, which is negative b over 2a, and I know b is negative 6, so negative 6 over 2 times a, and a is the coefficient of the x squared, so 2 times 1. So I've got a positive 6 on the top divided by a positive 2 on the bottom. The x value of my vertex is going to be 3. Now I want to find the y value of my vertex. So I'm going to take that x value of 3 that I determined here and substitute it into my function everywhere I see an x. So I'm going to have f of 3 is equal to 3 squared minus 6 times 3 plus 7. And so that's 9 minus 18 plus 7. So negative 9 plus 7, which is negative 2. So now I know that the coordinates of my vertex are 3, negative 2. So I can go ahead and plot that on an xy plane. Okay, now I do know from looking at this function that there's no negative in front of that first term, that leading term, which means I have a quadratic that is going to be opening up. If I had a negative here, it would mean there would be a reflection, and so it would be opening down. But I know that we're going to start with this vertex and it's going to open up from here. Now we're going to take a few minutes and find some additional points so that we can actually draw an accurate graph. Let's find our y-intercept. We can find our y-intercept by substituting a 0 in for x and solving for y. So f of 0 is 0 squared minus 6 times 0 plus 7, which when I evaluate that all is equal to 7. So my y-intercept is 0, 7. So if I add that to my graph, I know this much, right? Now how about the x-intercepts? I can have 0, 1, or 2 x-intercepts depending upon the placement of my graph. Now, knowing where I have my vertex and I know where this y-intercept is, I know that this is going to have that U shape, so I'll have two intercepts here. And I find the coordinates of those intercepts, taking my f of x value and substituting 0 in for that and solving for x. So when I see this equation, 0 is equal to x squared minus 6x plus 7, I want to be able to solve that for x. So I would first check and see, does this factor? Well, let me think about this. Factors of 7 are 7 and 1. So I can say positive 7 times positive 1. Do I add those together and get negative 6? Well, no. How about negative 7 and negative 1? If I add those together, do I get negative 6? Still no. And so in this case, this is not a factorable quadratic, which means I get to use my powerful tool, the quadratic formula, and solve for my x values. Okay, so substituting the appropriate things into the quadratic formula. My a is 1, my b is negative 6, and my c is 7. All right, so I sub everything into its rightful place. Now let's simplify. Negative 6 will turn into positive 6. Let's simplify this radicand. Negative 6 squared is 36 minus 4 times 1 times 7, which is 28. So 36 minus 28. So my radicand will turn into 8. My denominator will be 2. So I have x is equal to 6 plus or minus square root of 8 all over 2. That square root of 8 will simplify to 2 rad 2. And so I'll have 6 plus or minus 2 rad 2 all over 2. And then I am looking at these three portions of the output of my quadratic formula and looking for a common factor. I notice that a 2 is a common factor of all three, so I'll divide a 2 out of all three of those, and I will end up with 3 plus or minus the square root of 2. Okay, so that means I have x-intercepts at 3 plus the square root of 2 and 3 minus the square root of 2. Now, if I know that the square root of 2 is about 1.4, which you can get from your calculator, that means I'm going to have an x-intercept at about 4.4 and about 1.6. All right, so you can see that curve starting to emerge. And we're going to just do one more thing. We're going to add a couple of more x values and get the corresponding y values out just closer to my vertex. And then I'll be able to sketch my curve. So if I go directly to the left of my vertex and directly to the right of my vertex by subtracting 1 from an x and adding 1 from the x, let's find those values. So let's find f of 2 by subbing in 2 into our function. 2 squared minus 6 times 2 plus 7. That's 4 minus 12 plus 7 is negative 1. And f of 4, which should end up being the same thing because of the symmetry that you find in a parabola. So when I plot these points, I can really see that U shape starting to form. So now let's go ahead and sketch the curve, and I get that nice U. Okay, so now let's take a minute and analyze this graph. If I'm analyzing the graph of this equation, I'm going to want to be able to answer questions such as this. What's the domain? What's the range? What's the axis of symmetry? What is the max or the min? Where does the max or the min occur? And there's a few more that we'll do on the next slide. So thinking about the domain, you want to think about the graph in its entirety. What I'm looking at right now is just a piece of the graph. And to be honest, I couldn't actually draw the entire graph because it goes infinitely to the left and the right. It doesn't stop. So I want you to think about that. How far to the left and the right does it actually go? Because that's your domain. And you would say that the domain of a quadratic, any quadratic in this form, is going to be negative infinity to positive infinity. The range is a little bit different because for range, we're thinking about how far down does this graph go? What's the lowest y value? And what's the highest y value? Well, we can see that the lowest y value is found at the vertex, right? The lowest y value is y is equal to -2. And the highest y value, well, again, this goes on forever, so I don't really have a high. That just means that my range is going to be from -2 to infinity. And since we have a y value of -2 on the graph, we definitely want to include that -2 as part of the range. That's why that bracket is there. How about the axis of symmetry? Okay, the axis of symmetry is a vertical line that would split the graph exactly in half. Make sure when you talk about the axis of symmetry that you name it as a line, not just a value. It's kind of like people that get upset when you call them by their last name, but not like Mr. or Mrs. or Doctor. We want to name a line appropriately. Okay, so let's actually sketch the axis of symmetry. That's probably pretty easy for you to see. That vertical line there will divide your graph into a left half and a right half, right? And it's symmetric on both sides of it. And then we want to name that line. So when I'm naming the line, I want to think about what axis does it cross and where does it cross it? So this line here crosses the x-axis at 3. So this axis of symmetry is x equals 3. Now, every parabola has either a maximum or a minimum, depending on is it opening up or down. If we're looking at this graph, does it have a greatest y value or a least y value? And if you answered a least y value, you'd be right, because down here, it doesn't go any further down than here. So this is my minimum value. We have a minimum of -2. And where does that happen? That's the x value that corresponds with that minimum. Okay, so where it happens is at x equals 3. So the minimum is -2, and it occurs at x equals 3. Okay, we've got a couple more things to look at here. Let's look at intervals of increase and decrease. Okay, so remember that a graph is increasing if, as you're tracing it from left to right, your pencil is going up on your page, and it's decreasing if your pencil is going down on your page. So I have taken a moment and shaded these regions of the axis so that we can really kind of look at what's going on here. Notice that to the left of the axis of symmetry, the graph is decreasing, so I've shaded that blue. And to the right of the axis of symmetry, the graph is increasing, so I've shaded that yellow. So I want to know what is the interval of increase and the interval of decrease. So when I'm thinking about the interval of increase, I'm looking at this yellow section of the graph, and I'm thinking about what's the domain of the parabola that is in that yellow section. And you can see that that goes from 3 to infinity, right? 3 to the right. And then for the interval of decrease, it's really going to be 3 to the left, but we always name intervals from left to right. So -infinity up to +3. Now, where is the function greater than 0? This is asking you to look at the graph a little bit differently. And so we're going to take off the shading of the blue and the yellow, and we're going to think about where is the graph of this parabola sitting above the x-axis. So we're going to just kind of cover up everything that's below the x-axis and then think about what's the domain of these pieces. Notice there's two separate pieces because the part that connects them is below the x-axis. So I'd like to identify what's the domain of this left-hand side and the right-hand side. Okay, so the left-hand side is going from -infinity to where it crosses the x-axis, and we've got this decimal approximation, but it's really 3 minus the square root of 2 here, right? All right, and then on the right-hand side, after we come back up over the x-axis, it's going to be 3 plus the square root of 2, and that is going all the way to infinity. All right, so now let's think about where is a function less than 0. And when we're talking about the function being less than 0, that's going to be what is the domain of the portion of the graph that sits below the x-axis. Okay, and so that's the part that was missing before. So it's going to be everything in between those x-intercepts, right? And we know that this left-hand x-intercept is 3 minus the square root of 2, and this right-hand x-intercept is 3 plus the square root of 2. So from 3 minus the square root of 2 to 3 plus the square root of 2. And that takes care of the graph analysis for this particular graph. Now we're going to try another one here. We're going to go a little bit quicker. I'm not going to do as much explaining. And this one is a little bit easier. Okay, so we're going to just walk through it pretty quickly. We are going to try to graph the equation f of x is equal to negative x squared minus 4x minus 4. So before we even get started, I want to ask you a question. Can you tell me, by looking at that equation, does this graph open up or open down? And how do you know? Okay, so this graph should be opening down because we have a negative in front of that x squared. That means there's a reflection. And so that graph that is typically opening up, it's a positive smiling at you graph, right, is now reflected. So it will be opening down and kind of frowning at you. So remember that the first thing we did was find the coordinates of our vertex. We do that by finding the x of the vertex, which is negative b over 2a. And we know negative b will be negative 4, which will be a positive 4, over 2 times a, which is negative 1. So I've got a positive 4 over a negative 2, which gives me negative 2. Now remember, I find the y value of my vertex by subbing in negative 2 into my function. So f of negative 2 is negative 2 squared minus 4 times negative 2 minus 4. And when we put that all together, I've got a negative 4 plus 8 minus 4, which gives us 0. So we know that our vertex is going to be at the point negative 2, 0. So there we go. There's our vertex. And we know that this is going to open down, right? All right, so now let's go ahead and find what we need to find. We want to find our y-intercept by substituting a 0 in for x. So f of 0, that's easy. F of 0 is negative 4, so our y-intercept is 0, negative 4. Plot that. And then let's find our x-intercept. Oh, but our vertex is on the x-axis, which means that will be my x-intercept. But let's go ahead and do it algebraically just so you know how to do it. 0 is equal to negative x squared minus 4x minus 4. So I want to see if I can factor that, but I do not like factoring when my leading term is negative. So I'm going to multiply everything through by a negative 1. And that's going to make it 0 is equal to x squared plus 4x plus 4, which we know will factor to x plus 2 times x plus 2, or x plus 2 quantity squared. So that gives me x is equal to negative 2. Nothing more to add to my graph from that since I already have that as my vertex. But let's go ahead and add a couple of more points. Some x values close to my vertex will go to the left one and to the right one. So we'll do f of negative 3 and f of negative 1. So f of negative 1 is negative 1 when I sub that in, and f of negative 3 is also negative 1. So when I plot those 2 points, I get that U-shaped emerging, and I'm ready to sketch my curve. Okay, pretty graph. Okay, that just shows how geeky I am. All right. So then let's do the analysis. Can you tell me about the domain? The domain here is going to be negative infinity to positive infinity because this graph goes infinitely to the left, right, and infinitely to the right. Your range is going to be low to high, so the lowest values on this graph, that's negative infinity. but it goes all the way up until the y value is 0 and it stops there. So we're going to go from negative infinity to 0, and we're going to bracket that 0. Axis of symmetry, sketch it and name it. If I sketch it, I have that nice little dashed line there, and if I name it, it's x equals -2. Now, what is the max or the min? What is the high point or the low point, okay? So this will be a high point because this graph is opening down. What is the highest y value that this graph reaches? That will be a maximum of 0. And where does that occur? Well, that max occurs at an x value of -2. All right, let's do the intervals of increase, decrease, and where the function is greater than and less than 0. Shading our intervals of increase and decrease always helps. Okay, so on the left we have where the graph is increasing. The domain of this left-hand side will be from negative infinity to -2. And the interval of decrease will be from -2 to positive infinity, okay? All right, let's get rid of that shading, and then let's think about where the graph is above the x-axis. That's kind of a tricky question because this graph, remember, it doesn't go above the x-axis. It actually stays below, but just barely touches. The vertex is on the x-axis, so there is nowhere where the function is greater than 0. But if I'm thinking about where is it below, this is even trickier, right? Because is it below everywhere? Well, almost, because right here, it's not actually below. It sits right on the axis at this point. So everywhere on the left-hand side up until this point, and then to the right of this point. So we would say this is from negative infinity to -2 union -2 to infinity, and those -2's need to be parenthetical because we won't include them. All right, ladies and gentlemen, great work. Our next video will talk about graphing parabolas in a different form, and I will see you then.